Ready, set, go. Hey! Congratulations, sir. Welcome to the next talk. I'll get this to you in a second. Welcome to the next talk. We have a couple. Oh, fuck's sake.
Yeah, I guess that thing is no good.
Later tonight, don't go anywhere. We have a big banquet dinner and a diplomacy party. We will read all about that in the programs. If you're doing the room, you probably should have got a call by now to go and burgle the room. All the contests are still running. All the vendors and sponsors are outside. We have some swag if you want some more Tinder swag, Hackaday swag, all that kind of stuff's outside. If you are doing the demo party, you need to have your entry to ARCO within the hour. So while you're listening to Sam's wonderful talk, finish up your demo, get it to ARCO. If you are doing TAM testing, that is at 6 p.m. in the executive room right across the hall here. So if you're doing that, make sure you're there on time to take your test. Other than that, enjoy Sam Bowne with how to Trojan financial Android apps and SSL validation failures.
Yours this one?
Yeah, I suppose. So, I know Sam will tell you about this a little bit, but there was some controversy over this talk, and I was really looking forward to our first DMCA takedown rejection. I was going to
That would be fun, yeah.
Tell them no.
Yeah,
so
well.
Take it away, Sam.
All right, thank you. All right, I'm suspicious of this thing. Let's see if I can attach it to me. Can you hear me?
Yes.
Okay, if you can hear me, that's all that matters. All right, well, I have a few slides and then a lot of demos. All right, so I taught a mobile device security class, the first time ever, going through hacking mobile devices, and I had to apologize to the students for quite a lot of it because what's in the book is all fiction. There's plenty of secure practices well defined, and app developers just completely ignore them and don't do any of it. For example, OAuth. OAuth is a fictional product that makes it possible for you as an app to authenticate to some service like, say, Twitter without handling the Twitter password, but nobody uses it. They all blast right through, they handle the password and throw it on the ground where you can steal it. I can't find any example of anybody actually using it. I don't know why they bother writing it, but maybe for some future generation of people that care more about security. So anyway, Android is number one because it's cheaper. It is much, much less safe than iOS to an outrageous extent, entirely because of decisions made by Google to keep it free and open, and that makes it free to do stupid things you really shouldn't be doing, and they happen a lot. So, for example, apps have to be signed, but they don't have to be signed with a real public certificate. You can just sign them with a self-signed certificate, so what was the point of that? I could even download somebody else's app, take off their signature, modify it, and put on my self-signed signature, and it goes right back on. Now, if you leave the original app on, it'll say, hey, this new app does not appear to be a proper update of the previous one with the signature signing. We'll have to uninstall it first. Okay, well, that's all fixed then. So, So now Google has an official app store, but they don't actually keep bad things out of the app store very well. They've been humiliated with a series of disasters so that they're forced to be a little tougher every time about policing the app store. But, you know, I'm just guessing, you know, sort of like it's a religious issue. Why does Google do what they do? But, you know, it seems to me like they started with an open source ethic that you should just be able to do anything you want. And they're very reluctantly moving over to Apple's position where you should be like a child playing in a walled garden where your parents keep all the bad people out, which is a whole lot safer, of course, for most users. So the Android debug bridge lets you debug your device and send data back and forth. It's very nice and makes it possible to push things onto the app, onto the Android device, pull files back from it, observe the logs. Anything put in the logs might as well as be published on the internet. I mean, perhaps I've exaggerated a little bit, but it's available to every app on the device and available to the computers connected to the device. So one of the fundamental rules of Android security is never log sensitive information. You'll be hearing more about that. You can install things. You can open a shell on the mobile device and just execute Linux commands, which is fun. Now, an Android app is an APK file, which is just a container with a bunch of files inside it, and you can do static analysis on it far easier than Windows binaries. Windows binaries, when you decompile them, they turn into assembly language, which is relatively difficult to understand, but this stuff turns into Smalley code. And all you need is this APK tool, a free open source product. So I give my students homework to play with this, writing Trojans to an Android app. So you just run this thing, and it does its magic and turns this thing into just a whole bunch of little objects. And here's TD Ameritrade, a financial stock trading app. It disassembles, and I see all their source code. And you might notice this is really friendly. Consumer API, build config, account manager, base, cash manager. There's nothing to stop me totally reading their code. All the names of variables and such are easy to get. Now, Bank of America uses the standard obfuscator called ProGuard, which is built into Android suite, Android developer suite, and it's completely useless. ProGuard is like a security guard that locks half the doors and then goes home. As you can see, all these things are still readable. It took some of them and just turned them into A, B, and C, and I left a whole bunch of them just alone, like activities, enrollments, business credit card details, activities, just sitting here while the rest is like BR, BS, BT. So it does remove some of the names of the files and change them, but it leaves the variable names readable, so what was the point of that? And all the important functions keep their original explanatory name. And you might wonder, how bad is this Smalley code? Well, Smalley is Dalvik bytecode, and so here's Java, and here's the Smalley it produces. So if parameters put username here, put password there, it turns into username and password. It's really not a whole lot harder to read than just Java. It's a little bit strange. One thing you have to get used to is that you only have 16 local variables, and the local variables are called V, and the parameters are called P, and they come at the end, and they count against the total. And some apps actually use 32 of them, but the second batch cannot be used directly. You have to keep copying down to one of the first 16 to use them. But you know, 90% of the time, everything you might want to do to take over the app doesn't really require understanding much of that. So I learned how to do about 3 things in Smalley, and that's it. Now I own the world. So then all you got to do is recompile your app with APK tool. You build it instead of taking it apart, and then you sign it with your self-signed key, and now you can just put it back on the phone. So if you do, now, like I say, you should never put anything sensitive in the log. So you can monitor the log with a GUI tool, Android device monitor, and see things appear in the log. But it's a whole lot easier to just do from a command line with ADB logcat, because then you can use grep to filter all the log events and finds the ones you like. And so here I am looking for VFY or VERIF. This is actually very interesting. This is one of the very few successes from the work I'm talking about today. This is one of the people who actually patched their app. There are 3 or 4 of them, which surprised me, because most of the people I reported this stuff to would not talk to me, and the ones that did talk to me did not patch the app. But over the last couple of days, I said, well, before I give my talk out, I'll see if anybody listened, and a few of them did actually patch their stuff without telling me anything. So I'm kind of pleased to see that. They aren't all just ignoring it like I thought. So if you want to attack an app by decompiling and disassembly, you insert anything you want. Trojan code like keyloggers, you can find out what encryption method, you can do anything you want. And I learned a lot of this from Dancing with Dalvik by Thomas Richard. I saw him at B-Sides, and he showed us how to cheat at games with Dalvik. I said, hey, this is actually pretty easy. And I don't do anything hard. Nothing I do can be any harder than about a 2-hour homework assignment for my students. So that looks pretty doable. So here's how you take over the Bank of America. So you start with the Bank of America app, install it on an Android device, then you use these commands to get it back from the device so you can play with it. This is the shell command that lists the packages on the device, and then I use grep to find the B of A, so it has this funny name, com info now B of A. Then I use shell PM path to find out the exact path to the APK file, which is the single file that includes the entire app, and then I just pull that file down, so now I have it on my computer. Now all you do is use APK tool to disassemble that app, and what that creates is this whole tree structured mess. And let me just bring it up live here. So I have done this, of course, and I've redone it all over the last 24 hours to check for updates, so it's gotten pretty fast. FinApps is the folder where I put all these things, because originally I focused on financial apps. And here's the latest one, Bank of America 5. I did this to decide whether to do it live during the talk, and it took 10 minutes in my hotel room, so I decided to only talk about this part of it rather than trying to do it live. So this is the APK file that comes down. When you disassemble it, you get this folder. It has a few XML files. You can control the structure, and a lot of files that are going to end up in here, but all the code is in this Smalley directory, and you can see what they've done here. B of A wrote some custom code here. They have some Android libraries here. and then there are coms and orgs involved. If you go to com, various different people have contributed to this code. They've used libraries, and they're all in here. Here's the custom stuff they wrote, e-commerce, and in particular, let me just find the one that's funded Trojan here. I'll just go to this stuff live. Everything I'm going to show you is, hey, it's on that website, which is not loading because of the hotel Wi-Fi. There it goes. It's all down here. Here's all the security results I'm going to report today. This is the landing page that leads to all the rest, and if it's going to load slow, I'm just going to look on my slide where I've got it. See, you can search for this stuff with grep. I wandered around. Usually I look for password. If that doesn't work, I look for user agent, user ID, and a few other things. And if that doesn't work, I just start wandering through the routines, looking at things. And when everything fails, I wrote a tiny little Python script about 10 lines long that Trojans every module in the whole app. So it runs slow, and the log just screams. And every single routine that loads, it puts out a log message every single app, every single module it runs. And then I get to the login screen and start logging in and see what runs at that point to try to find what part is likely to have the credentials. Anyway, this one here was SmileyCom, B of A, Ecom, auth, activities, enrollments. So anyway, I think I'll just stick to the slides for this one. So you see auth enrollments. Here's the file, business credit card details activity. That's the one I found that handles credit card numbers, and I thought those might be fun to steal. So when you look at the code, this is what it looks like. Now this is the glorious obfuscator. The function is now named L instead of whatever its original name was, but the string is still called B of A. Oh, that's the one I put in, pardon me. But this here is still called set card number. That's how I found it. So this is all the Smalley I know how to write. Well, I know slightly more than this, but not much. I changed the number of local variables, so I have another one to work with. So before it was 3, so it only had V0, V1, and V2 are the only variables you can use in this routine. And I don't want to step on one of those and change it so it'll break. So I changed it to 5, so now I can use V3 and V4 with impunity. And in fact, I ended up using V3. And here's the main Trojan I always use. The only thing I figured out how to do, I forget why, maybe I copied it from some blog or something, but you can make a constant string and you can put it in the log with this. This makes a log that has, this is the name of the item and that's the value of the item. So I figured this thing in V0 is a string. And it looks like it has something to do with the card number. So I just want to see what it is, so I put B of A Trojan card number right there, put out V0. And I want another one down here that says set CVVs. That sounded pretty good. So I dumped that one out. And that's it. The only thing I learned about Smalley is that when you see a function like this, the result goes in the one on the right. Anyway, so that's the game of that. Now you rebuild the thing with Java jar, and then you sign it with a self-signed key, which is just canned routines. By the way, APK tool often gives you a screen full of error messages when tearing things apart, and another screen of error messages when putting it back together. And I've always found you can just ignore those and everything's fine. I don't know what they're all about. I thought somebody actually fixed something the first time that happened, but no, it complains about ping files a lot, but everything seems to work. So let's play with this thing. It's easy to see what it does. So I got all these apps here we're going to play with. Let's get the log up. ADB logcats. We'll start with this one. Okay, this shows you everything that's going on that Android device. And when I launched the Bank of America app, it has a whole bunch of junk going by, which is kind of irritating to see all this junk happening. So I'm going to filter it for the word Trojan, because this is the Trojan one. And the hotel Wi-Fi will hopefully knock off being so slow. Let's see if this page ever loaded. All right, if it's going to be like that, let me see if my phone's any better. All right. In fact, I've learned from experience that the USB works a lot better than the Wi-Fi on the phone, because I think a lot of these slowdowns are local Wi-Fi interference. Did all right, well. All right, I will use it, but I'm keeping the phone around to scare it into submission. So, no, it didn't. All right. So let's connect through my phone and see if it's any better. This is a common problem in hotels. That's why it's nicer to give talks at colleges. But they don't let you have any booze. So we've had the first B-sides with no booze in San Francisco, and there was not a riot like I thought there might be. So we may be able to move towards colleges, which would suit me better. All right, let's see if I actually get any better joy out of this thing now. I don't care about your stinking iTunes. Let's see if I can get on the internet yet. That's a bad sign. Trust this computer. It's not the right question. See if I can get any kind of internet service here. That's not a good thing. Off. On again. Oh, I see. I don't even have 3G or anything in here, do I? All right. Apparently, I must attempt to use the hotel Wi-Fi. Is there anything that works? Yeah, if you got anything that works, I would like to use it. Because my phone is not getting any signal, and the hotel Wi-Fi is quit working too. It worked when I was in the audience, but not up here. So what do I do? Just choose a wireless network of some sort? Oh, that's the credentials? Good, good. Let me turn on my Wi-Fi. Let's see. Thank you. Copernicum. All right. I should be able to see it. Let's see. Well. It says it's looking. There it is, Copernicum. Good. You want to type in the password? Come on. Good. You're a champ. And I won't retrieve that password from the machine. Now that's a password, all right. That's pretty impressive. All right, thank you. Let's see if I can get on the internet now, without which things are no fun. Now what is this? I'm still not on the internet? Oh, now I'm on the internet. Ah, good. Thank you. All right. Ah, good. Retry. Yeah, looks like it. Aha, something happened. Life is good. All right, so here we are. We're glorious. Now we can enroll in banking. That's what I want to do. Get started with a small business credit card. So here's my credit card number. And I've got a month and a year, and I've got a CVV, and I've got a Social Security number. And when I continue, there they are. They all just get dumped in a log because this is a modified app. And this thing is communicating with the Bank of America servers cheerfully and stealing the data as it goes by because the Bank of America just don't care. It might be worth mentioning that I told them about this in February and got no answer at all. All these people have known since February or March. And most of them don't respond at all when you talk to them. And the ones that do just make promises that don't come true. So let me try the Bank Corp. I chose to show you different categories of Trojans that I made that I thought were interesting. Bank Corp is an interesting case. In Bank Corp, they used something called the Secure UI module, which meant that this kind of Trojan wouldn't work. They don't actually load the password in a single variable that I could find, but I can catch the keystrokes. 1, 2, 3, 4. So that'll do, really, to prove the point. And let's see, next one was, there were 4 different categories of all the ones I did. Capital One, I forget what was different about this one. Let's see. I can tell from the slides, I think. Yeah, Capital One, that's right. Capital One's worth showing you. Capital One uses Google Cordova, Apache Cordova, whatever in the world that is, some developer might know, and it catches the keystrokes here. And by the way, both of these irritated me so much, I had to just Trojan everything, and then I noticed the same thing would run every time I hit a key. I said, okay, I'm going to that thing. So now when I go, let's bring the log up. Okay, so now when I bring up this user ID, it's going to be Flapjack, and the password is password. Okay, you're getting these key numbers. Now those key numbers are not ASCII. They are some nonsense Google made up. And they put them on a page that I can find where they have like 1 per page for 255, and you have to scroll down and sort of put them back together. But anyway, it is possible to turn those ridiculous things back into letters like this, 29, 30, 31, and so on. The password is included in that nonsense. It's just in a slightly irritating manner. So it does sort of prove the point. And of course, you know, if I just added any code and then recompiled it and it ran, that would be enough in principle to prove that the developers made a serious error. They should have validated their code. But this is, as far as I can tell, my entire contribution to this business is theater. The point is you have to impress people. And they won't care if you have some theoretical problem. They want to see you really stole the credit card number. They can understand that. That's why I always try to make where you really get something real. So SunTrust, I was not going to test SunTrust. I was working from the top 10 banks I found in like a U.S. News and World Report article or something. But I put some of this information on Twitter, and somebody said, did you try SunTrust? And I thought he was a SunTrust executive. So I tried SunTrust, and it turned out he was just a SunTrust customer. But anyway, SunTrust turns out to be both important and interesting. So let's take a look at SunTrust. And they're friendly too. These guys responded when I reported to them, and their security officer talked to me, and he said, oh yeah, that's important, and we'll really fix that, but we're not sure when. And I don't know when either. It hadn't happened yet. But he said it's not under current active attack, which is an interesting point of view because this was all under active attack in 2011. But maybe they have moved on to other things now. Anyway, here's SunTrust. My user ID is user. Come on. Okay, user ID. My password is LayerOne. I log in. And here's what SunTrust gives me. It puts them all over the place. What I had to do was Trojan all the parameters being set out the network. Here's the layer 1. Here's the name. Here's the password and the user ID. What I did here was Trojan the routine that creates HTTP requests and sends parameters out. That's why there's all this other junk. This is the value and name of every HTTP parameter being set up. But it's good enough to catch it. You know, and so the only thing that makes this difficult is that many developers include many routines they don't use. So when you grep for password, you find 100 of them, but only 2 of them are actually used. All the rest are legacy code they brought in and didn't bother using. Anyway, so that's the game there. So Trade King is the one I wanted to show you. Trade King is one I found out yesterday actually patched their app, which caught my attention because it's interesting. So let's go back to just a plain old logcat here. So we're seeing everything happening on this device. I go back here and run Trade King, which is some kind of stockbroker trading activity. And by the way, when things crash, oh yeah, that's right. This one actually means it when it crashed. This is the Trojan app, and it won't launch anymore. It used to. And if you want to know why, you can see right in the log, right here, runtime exception, this log, let me just do it again. Fatal exception, there. Fatal exception, comms echo mobile activity login. And up here, we're going to see verifier rejected class login. And that's where I put the Trojan. So what these guys have done now is they put in some kind of verification of their code that notices that this module has been altered and refuses to start. And that is exactly what I told them to do. I said you should validate your app. Now I thought they would validate the signature, which it seems to me would do the whole thing, but they didn't do that. They validated the code. Now, I don't know how they did it. I think I just found out about this a day or two ago. I wouldn't be surprised if the verifier itself is somewhere in there and I could find it and turn it off. But still, I still regard this as progress because that's all security ever is. The cops get bigger guns, the crooks get bigger guns. I mean, they made it harder. That's all you can ever do. Then it'll slow down people, and there are probably maybe more perfect solutions, but at least they did something, which I appreciate. So let me see if I can get my general summary page up here. Here we go. So this is the first. Now, what I'm doing here is talking about known vulnerabilities. On Twitter a couple months ago, I called these things 0 days, and they all yelled at me. They're not a 0 day, they're using the same old principles. They're right, not a new principle, just vulnerabilities that have not been patched. This one is M10, lack of binary protection, where you can modify the code. So that's the first one I looked into here because basically every app has it. It was something like 8 out of the top 10 banks, 9 out of the top 10 stockbrokers, 7 out of the top 10 insurance companies all had this problem. So it is something like 80 or 90% of all apps are vulnerable. And here they are, the Bank of America, Bancorp, Capital One, Chase. The ones in green have actually fixed it. M&T and Wells Fargo. Wells Fargo probably because one of my students is like close to the head of security there and was able to make a personal plea, I think. SunTrust promised to fix it. One thing that was kind of entertaining was Charles Schwab. So Charles Schwab was vulnerable to this. And when I tried to contact them, it turned into a real circus. Oh, by the way, one thing I wanted to make sure and mention here, which I think is a really bad idea, is that absolutely none of these people have any vulnerability reporting process, far from bug bounties or anything. there is not even any address to send anything to. And if you send security@company.com, it just bounces, with a very few exceptions. So they're so far back in the dark ages, they're pretending that they have no problems and they don't need to hear from us, which is an unwise place to be. And anyway, there are a few exceptions, but anyway, Charles Schwab is notably not one of those exceptions. So I Trojaned this Charles Schwab app, and then I tried to tell them. They have an email form, which is just broken. An error occurs when sending the email. Then I send email to security, but that just bounces, of course. Then I found another email form at the UK office, which doesn't work either. So then I sent to the international office at Schwab, and I was able to send an email that didn't bounce, but then I found a website that says there's no point emailing Charles Schwab. They ignore everything that comes in every email address. You're just totally wasting your time. So I switched to something which I have done several times with great success, which is you look up the CEO on Twitter, and then you tweet him. Please follow me. I've actually never failed with this approach. I don't like it because it's tantamount to full disclosure of public vulnerability, because I'm not willing to bother CEOs over nothing frequently to create background noise. If I ever tweet a CEO, anybody can guess exactly what I have to say. And that's, of course, what happened. Swift on security, of course, figured out what I was saying. And so this is like, this is not good operational security, you know. But I've never had it fail. The CEO does get back to you right away, and this is a fundamental rule I've learned about vulnerability disclosure years ago, which is the person that created the problem will never fix it, or usually would admit it exists. Although I have one counterexample coming up later. Anyway, so he contacted me, and he put me through to their security team, and they sent me through to the right person, and he said, "Oh, for God's sake, if you find something else, don't go to the CEO again." So I did find something else last week, and I sent it to him, and I didn't get any answers. So we're going to see how far that goes. But anyway, they also did not fix their stuff. Charles Schwab is still vulnerable. All these trading apps are vulnerable. And TradeKing, however, is one of the few that did fix it. And here's the others: Wells Fargo and MT Bank. Those are the only three people that actually fixed an app. Now, you'll notice down here in insurance companies, Geico and Intuit TurboTax get yellow because they didn't fix anything, but they do have a page to report vulnerability problems in. Geico has a very nice page. As, "Are you a security researcher?" As if they understand what we are. But then when I tell them, they ignore me and do nothing. And one of them, I think it was Geico, actually promised that they would have it out in the May update, but then they just didn't. And then I talked to their security guy again, and he said, "Oh, the team told me they were going to obfuscate the code." And I said, "You don't have someone test?" Well, you know, it's not hard to test. Everything I know I learned from that book, and my students do it for homework. I mean, I didn't get rude discussing with them, but you know, it doesn't seem to me like I should need to tell somebody in that position that when you tell an employee to do something, you then have to test to see if they did it. But anyway, all right, let me go back to here, because there's more categories of trouble to talk about. So anyway, like I say, one defense that a lot of people told me is this doesn't even matter. Trojan's not really ever going to happen. You're just making it up. It's not a realistic threat. And I don't think so. Because remote place, now you might reasonably say, see, if this was an iPhone, none of this would happen, because you have to install things from the store, and Apple actually polices the store. If you put a Trojan app in the store, you get kicked out. Just ask Charlie Miller, and they're not messing around. Android just doesn't do much of that. They don't clean the store very well, and people install stuff that's not from the store. But if everyone was required to install things from the store, then Google could control this, but they're not very interested in doing it. Now, they did some of it. They took out the Droid Dream ones that were Trojan in 2011, but their application verification service is just fantastically ineffective. This is how effective it is compared to all the other antiviruses. The bouncer thing is just not very successful. Anyway, you can protect yourself here. One thing you can do is obfuscate your code, so it's very hard to read and find where to put the Trojan, and that helps, although it's not a very strong defense. There are also products you can buy that will block reverse engineering, make APK tool not work, and they can get pretty expensive. And by the way, -O is an obfuscator that actually works. This is what you have now, and this is what all the variable names have turned into this garbage. See, that would irritate me. I might not get interested enough to write this talk if I had to wade through all that garbage all the time. So that's a reasonable obfuscator, but it costs $2,000. And there's another product called ArcSan, which won't even talk to me because I'm not going to buy it. So it must be even more expensive. And they claim it has multiple layers of validation and verification and checks so that you can't decompile this stuff at all, and it recognizes all the decompiling tools and breaks them all. And I imagine that's probably true. They won't give me a free sample to test it. But you can totally buy products to prevent this, and I'm wondering how these people stay in business since nobody seems to care. But apparently some of them do care. Some of them actually patch it. So it seems to me that there's a slow awakening that there's actually a problem here. Anyway, so that's as far as this last one, lack of binary protections. So then I started noticing other stuff to look at. And one of them is some old work from CERT. In 2014, CERT actually built a special gadget we used to call the Tapioca, I think using a Raspberry Pi or something. It was a sort of like a Wi-Fi pineapple. It was a man-in-the-middle attack that would then put a whole bunch of invalid certs to every website you went to so they could see if any of the Android apps would accept invalid certificates. And they had all kinds of errors, expired, wrong host name, invalid CA, and so on. And they found 23,000 vulnerable apps. And they notified all the app designers 7 months ago, and they published the entire list in a spreadsheet on the internet. So I was looking at this thing saying, this is interesting. I wonder how many of these people actually patched their stuff. So I started looking through, and I made a page here, and this started to get me in trouble. So this is repeating previous CERT. You see, what I said to myself here is I do not need to do responsible disclosure. CERT already did responsible disclosure 7 months ago, and if they don't listen to CERT, they're not going to listen to me. So these guys are fair game. That was my hypothesis. So here's PixArt, Astro File Manager. This is stuff with like 100 million downloads. So I had this spreadsheet of 23,000 things to test. First, I started testing the ones that had the most downloads because they looked important, like OkCupid and Safeway and such. And these are susceptible to SSL man-in-the-middle attacks. And then we'll get down to the mobile ones. But this is one that's so extreme they actually fixed it. It was Foxit Mobile PDF Reader because they got embarrassed. But let me show you how this one works. This one is slightly more complicated. Not very much more complicated because I don't do anything complicated. So you have to use a proxy. So it's, I don't know my address anymore because I'm using a different Wi-Fi. Let's find out what my address is. Okay, it is 192.168.1.131. Okay. So I will send everything through 192, 168, 131, and port 8080. All right. And I'm running burp here, and burp is listening on all addresses, including that one, 131. So I have a man in the middle. Now, if you want to use burp correctly, you have to install the PortSwigger root certificate in your device so it will be trusted. And if you don't know what you're doing, you install burp incorrectly, and you get these warnings every time you try to browse to a secure site. But that's what I want. So now I have put a man-in-the-middle attack that does not have a valid CA, so no secure connections can be made from this device right now. So if any of these apps make secure connections, they're lying. And of course, they do. So here's the history. Here's it attempting to connect to HTTPS resources, and these aren't getting anywhere because it couldn't get through. Let's clear the old stuff and play some games here. So let's see. We did SunTrust and Trade King. Here's PixArt. I don't know what they do, but whatever it is, they do it badly. Here's HTTPS connections. Here's HTTP post connections going through, carrying some data about my device. So they're making these HTTPS connections. Now the port 443 is open, and you can make the connection, but the certificate is no good, and they obviously just don't even check it. So I can find a login button someplace. Here we are, login. And I can put in LayerOne fool, and I trust you here, and sign in. And it'll be right down here someplace. Maybe that one. Somebody there. Here's a post. There we are. I trust you, LayerOne fool. So it appears as using what they think is HTTPS, but they just commented out the HTTPS validation, probably just so they could test it, and then just never put it back in. I mean, I'm not a developer. I don't know exactly what leads to this, but it is something a lot of them do. And I'm surprised that Google doesn't block you from the store for stuff like this. I think Apple would. I mean, they could just run a test. It could be in Bouncer, and what do I know? Maybe I'm just underestimating the difficulty of this, but it seems to me like they could be in Bouncer if you accept invalid certificates, kick you out of the store. And you know what's kind of fun here? Suppose you try logging in with one of these other services. See, Google Plus, I can't get in. Now, that's because PixArt is not as stupid as they could be. When you click on these external links, they appear to be launching an external browser, which is probably the default browser. And see, the default browser is smart enough not to let this happen. We are going to see that is not always the case. Anyway, so I'm able to steal PixArt credentials. Then I got InstaChat, which is something related to Instagram, whatever that is. I don't use it. I just mock it. And here they are wanting me to log in, so I'm test, user, LayerOne, password, LayerOne. I log in. Don't bother remembering it. That wouldn't be secure. And so there it is, test user 1, password 1, stolen by the man-in-the-middle attack. So they're just throwing the passwords on the ground like they don't care, and here's OkCupid. And see, OkCupid used to be vulnerable, and they patched it. They're one of the services that actually paid attention, so I appreciate that. They now warn you. So that's not bad. I suppose if I trust the network, it'll fall for it. I haven't tried that one. And then let's try the Safeway app. You can do stuff on your Android phone at Safeway. I'm not quite sure what it is, but you can go to My Card and get to the personalized section where you sign in as Safeway user at AOL.com. My dog's name, sign in, and there it goes, just spraying that stuff all over the world. And then it went to the server, and the server noticed that's no good, which is evil. It should have told me, you know, that I can't get there from here because something's wrong with your network connection. So that's the game there. PixArt, InstaChat. No, these two are 100 million each. OkCupid actually fixed it. Safeway's only 1 million, but you know, and there are a lot of them, like more than a dozen on that list there that I tested. And so then, that was pretty entertaining. And I said, well, you know, the other thing that occurred to me is you can take the spreadsheet that came from search and you can sort them by category. And there's a category called medical. And it seems to me like some of those guys might be covered by HIPAA. And I've had pretty good luck in the past at getting attention by reporting HIPAA violations, especially if you go right to the feds, which I haven't done with these yet, but I have gotten far enough to get some attention. So I just took the same. Now, the reason why anybody ever cared about this is because Dan Gooden at Ars Technica wrote this stuff up. So there's actually an Ars Technica article about this one, which had the first part of these things, where he talked about the fact that these clowns haven't patched their thing even 7 months after being told by HIPAA. And what's surprising to me is that Snap Secure was a security product, which we had this problem, and they did in fact fix it pretty quickly, because that's pretty humiliating. And the Foxit mobile PDF reader had social networking options. Let me just bring up this here, because this is pretty fun. There were 2 or 3 things that had this kind of stuff. If you're determined enough, you can compromise other people's services too. So, let's see if I can get this to go to the right place. With my somewhat slow Wi-Fi, let's try Foxit. Okay. And the next occurrence of Foxit. Okay. So Foxit mobile PDF reader, I can harvest Foxit credentials here. But then Foxit can connect to cloud readers. And here, let me just open a local copy of this page since the internet doesn't work. That's the logical solution. It will take me a moment to remember how to find it. Here's this one and this one. There we go. And I should be able to run local copies of all these things. There, all right. And now, it's this one. And now this stuff should move. There's Foxit. Okay, so here's the Foxit reader, 1 million downloads, and see, Foxit can connect to all these services to get the PDFs you want to read. And when you do that, it does not go and launch the default browser like it should, or use the system routines. It uses their custom junk they wrote that doesn't work. So this looks like a browser, but they wrote some version of a browser that ignores certificates. So I can steal your Dropbox password, and your Box password, and your Microsoft password as you connect to the Microsoft cloud, and so on. They expose all these other passwords by connecting them through their own insecure custom code. So when I put that out on Twitter, and they actually patched that one pretty fast. Anyway, let me go back to my list here. So the medical apps are the next thing that I wanted to look at because it seemed to me like these guys violated HIPAA. Now, I'm not a lawyer, but I went and looked at HIPAA, and it says you are supposed to ensure confidentiality, integrity, and availability of medical information. If you are a covered provider, and there's various categories of covered providers, but pharmacies are included, and so are doctors. So there's something here called Genie MD, and this thing is a product you use to manage your health, and you enter your medications and your vitamins into this thing, sign in using email, and I can steal the credentials. And what Genie MD claims is that the patient is not a covered entity. The patient is allowed to use something insecure to store their stuff. And therefore, this is not a violation of HIPAA. And I looked at the third category of covered entities, and I thought maybe they're included, but I don't really know. But I said, you know, why do you break SSL anyway? But I got no answer beyond that. They sort of lawyers answered that they're not eligible. Go away and shut up. Anyway, but the other one that was entertaining was, let me go back to my slides here. All right. So here's all right. Notice this one called Lowest Med. Now, this is the spreadsheet from Search from 7 months ago. Here's the medical category, and there's something here called Lowest Med Corporate. So I went and looked at Lowest Med Corporate. Here's Genie MD, and here's Lowest Med Corporate. Now, Genie MD responded immediately when I put this on Twitter, we are not covered by HIPAA, we do not need any security, go away. I said, well, that's an interesting position to take. Lowest Med contacted the college. I sent them an email telling them about this, and they ignored that and called the president of the college and demanded that they said they were going to sue the college if I didn't take that page down. And then I said, pass the information on to me, and I replied in writing saying, why don't you put whatever you have to say in writing, not on the phone, and then I'll run it past my lawyer, and we will take an appropriate response. And suddenly they got polite and said, well, you know, we think we're probably not covered by HIPAA because there's nothing personal in our product. And that might be true. Let's take a look at these guys. See, I cannot test these guys too thoroughly because without a valid credential, I can't see exactly what they do once you get inside. But let's move this thing and go here. So here is Lowest Med. Now this is a corporate product that is used to buy medicines. And so here we are, username and password. My username is test user and test, I'm messing it up, but it's all right. Test password, all right. And there it goes, sending test user, test password up insecurely. So I do not know what's behind this. I assume a list of medicine you're buying, and I think there is a sort of disingenuous issue here about how I've only stolen the password, that's not medical information. I say, yes, what's behind that password? But anyway, I do understand the whole point of lawyers is to split hairs. Anyway, then there's Genie MD, which is more of the same, really. Genie MD is a product you use to keep track of your symptoms and so on. There's something called My Genie MD, which I think you can use to order medications, and that would make it covered by HIPAA, but maybe not. And anyway, to log in, looks like, yeah, I already have an account here. Let me just delete my old data. I tested it earlier, and I have to clean it after each test for this one. Genie MD, clear data. Okay, and now here's Genie MD, and we'll clear this old stuff. And now when I go to My Genie MD, I need to sign up. And I can sign up this way. There are terms of use, which, by the way, I don't need to see to agree to, which is entertaining. Okay, so user, okay, that'll work fine. All right, so I put in some stuff and sign up, and of course that is available to be stolen on the internet. And then it's going to ask me this stuff: blood type, gender, are you pregnant, zip code. You know, this is PII, but anyway, they're going to argue whether that's enough of a crime, and I don't know. They may slide on HIPAA, but I'm hoping they have some motivation to actually fix their junk. Anyway, so then I decided, you know, I thought CERT caught them all with their automated process, but then I just tested some random apps, and they were vulnerable. So I do not know how CERT missed them, or if they added new vulnerable ones in the last 7 months. This might be the answer. But I started trying a lot of apps, new ones, and I found a lot of them vulnerable to this man-in-the-middle attack, and I contacted them saying I think they're violating HIPAA. And one of them really takes the cake. There's a Blue Cross Blue Shield of North Carolina, and the reason I can talk about them is these guys had the worst vulnerability, but they're the fastest to fix it. So they fixed it within 2 days, which was yesterday. So I was able to actually talk about it now. The rest of this stuff I'll have to wait like another month before I can talk about it. But they have 2 apps, Blue Connect Mobile and Student Blue Connect Mobile. And those things leak your Blue Cross credentials, Facebook, Twitter, and YouTube credentials by not verifying their certificates. And so I told them, and they fixed it in 2 days, and now, as soon as you try, it just says the connection is not secure. They're really very nice. So the developer is really a hero here, responding quickly to a report. And the last thing, this turned out just right. You got 10 minutes, and I threw one thing at the end I thought you'd get a kick out of. I was trying to do insurance companies. And this insurance company called AIG did not have an app, but they had some weird thing called AIG Mobile Guard. So if you buy their insurance and you want it to protect your phone itself, you have to install this security product on your phone to protect it, which I guess lets it be remote wiped and remote found. And that product is fantastic. You notice how all I've been talking about is when I Trojan an app, I put the password in the log. Because that's so ridiculous, that proves that I'm able to destroy the app. So I wrote a Trojan for this one to put the password in the log, and then I looked, and the password was already in the log. So there it is. It already logged the password. Dude, I have this special app written to be insecure that my students do for homework. And I'm like, dude, I could just use your app. It's like the example. It comes pre-Trojaned. And so I contacted them. It also has local storage of all your data. It stores your security question, your security answer, and your PIN in plain text on the device. And so anyway, there are 4 versions of this thing. And I thought it was probably worth showing you. Yeah, I think there's 341. Good. I should have enough time to demonstrate this one. Let me take a moment. Let me quit going through the proxy because it makes everything slow. And we're done with that part. Here's Mobile Rescue. Let me delete the old data for Mobile Rescue because you only get to put in data when you first, good, the data's already gone, good. All right, so all I have to do is get rid of the proxy, which is here. Okay, so now I'm just connecting directly to the internet. Now let's get the log going by, which looks like it is going. Right, and I think the thing to search for this one to avoid getting a lot of junk is encode, okay? So I grep encode. Okay, so now you start this security product that protects your phone. Mobile Rescue, I've agreed to this, whatever it is. Activating the product. Yes. There we are. They made a PIN. But if I change the PIN, I changed the PIN to something real secure like that. And then I put in my mother's maiden name. And I hit next, and there we go. There's the PIN 1337. In case you didn't get it, there it is again. And now I'm going to put in more stuff, and it's going to log. So that's pretty entertaining. So I contacted them, and they said that they patched it, and they didn't patch it. They're just lying. They said it was their old products, and they have new products that are better, but I kind of doubt it. Anyway, let me see if I got anything else here. I think that's all I wanted to show you is those things all failing. Yeah, so you got any questions? I'm interested in hearing them. Yeah?
To mitigate the key logging aspect of Trojan, because that's all done on the app side. There's no way to do external verification, but for external verification of app validity, would it be possible to have a hook in the app store itself that you have to send and get a ticket back that is some kind of a check on the app integrity? Because the problem is that you're in a situation where I can't figure out how to actually solve this problem in a way that you can't Trojan yourself out of.
I agree with you, and I'm hoping somebody smarter than me will solve this problem. The only solutions I can think of are pretty weak, like obfuscating the code, validating the signature, but of course whatever validation you put in is code in the app. So it would be better to have some kind of cryptographic thing that can't be forged, or you send some kind of hash with encryption with a public key cryptography or something going to some trusted server. I imagine somebody could think of a good way to do that, but I don't think that's what people are doing to block it now.
It would have to be like in the Play Store. It would have to be pre-existing on the system.
Yeah, that would be good. And I agree, I would like to see some intelligent thought put in how to prevent this, but at the moment, nobody even cares. So, I mean, I'd be happy if they would just use the lame measures that are available now, and then if they were doing that, we could argue about how to make something better. Yeah. Any others? Yeah.
With the SSL fails, did you get any sense of what was kind of the common root cause? Was there right around cert validation, not validating certs, not using the trust store?
I do not know exactly what they're doing wrong to create these SSL validation problems. And by the way, I should mention, in case I didn't, that the test I use is much less precise than the one CERT used. CERT tried all different kinds of errors. I just tried one error, untrusted CA. So they might not be verifying the name on the cert, and I would not catch that. But still, I just used the easiest thing. And what it appears to me is just a lot of them have commented out all validation entirely and just left it that way because you can use it for years and the customers will not notice. Yeah.
Do you come across many apps that disregard the system proxy setting?
Yes, I'm glad you brought that up. Quite a few I cannot test in this manner because they do bypass the proxy and make a direct HTTPS out. So that's another reason why the CERT test is better, because they put a real device in the middle so they have no chance to go past it. So I mean, I just did the easiest test and it's relatively sloppy, but it catches a lot of them. Yeah.
I don't know if it's still the case, but you had mentioned that using the default browser could solve a lot of this. I think Android's default browser doesn't do CRL checks. So if you got your hands on an old cert or key or whatever, I think you can still man in the middle with an expired certificate, and the app won't actually go out and check for that, even if it uses a default browser.
Oh, you mean it doesn't do a revocation?
Yeah, it won't actually check for revoked certificates. So
well, that's interesting because I know Chrome does, and Google had their special technique.
Chrome actually has a hard-coded list they're maintaining now, because that's a great idea.
And they didn't put it in Google's default browser.
Well, I don't think it's implemented because Chrome is separate than the default browser, and that may have changed in Lollipop, but I think before that they were not doing CRL checks. So.
Boy, I'm glad you told me. I did not know that. Yeah.
Can you talk a little more about your Python script that went through and iterated all the variables?
Yeah, it's really very simple. It looks at the start of every app, finds a number of local variables, increments it by one, and then inserts a standard thing that just says what the name of the module is, puts it in the log. And